Okay, so today we will talk about the real life examples of conservation of momentum. We've learned already that the momentum is conserved in an explosion. And today's example we will discuss is when the rifle is fired. So, when the rifle is fired, before firing, the total momentum is zero because both of the objects are at rest. So, their velocities are zero, hence, their momentum is zero, although they both have mass. So when the firing is done, they receive equal but opposite amounts of momentum. So the total momentum after firing is zero. So look at this example. So we have a gun whose mass is 3 kg and a bullet is fired. So when the bullet is fired, the bullet moves forward. And as the bullet moves forward, without any without any external force acting, the gun recoils back. This is obvious, evident from experience. The gun recoils back. So this recoiling, why it is happening? It is because of the momentum that has been gained by the bullet. So the momentum cannot go in one direction because it has to be conserved. So it has to go in the backward direction of the, so it has to be of the gun because before firing, it was just one object and it was at rest. After firing, it split into two objects. So it's kind of an explosion. So the two objects must, if one of the object gains some momentum, listen carefully about these. Listen carefully to these words. When after collision, one object gains any kind of momentum, the other object has to have an equal and opposite momentum. This is the law of the nature. So this is what happens. The bullet gains a forward momentum. It gains an enormous velocity of 175 meters per second, and its mass is only 30 grams. So this momentum is in the forward direction, and equal and opposite momentum must be gained by the other object from which it is separated, that is the bullet. So the gun has 3 kg mass. So our task is to find, as the exam question will appear, our task is to find the velocity with which the gun recoils back. So calculate the recoil velocity of the gun. So we have this data, mass of the bullet, velocity before firing, after firing, and velocity of the gun after firing. Before firing, they were both zero. So we apply the momentum, the conservation of momentum. Momentum before firing should be equal to momentum after firing. Momentum before firing was zero. Momentum after firing is obtained through these. So we have the gun momentum and the bullet momentum. The gun momentum, the mass is 3 and velocity is unknown, plus the bullet momentum mass is 0.03 and velocity is 175 meters per second. So this makes a very nice equation, and with one unknown variable, so we can easily find this one unknown variable by readjusting. So we bring 3v onto the left side of the equation, becomes minus 3v. This after multiplication becomes 5.25, and then minus 3 divides this, and the answer is minus 1.75 meters per second. And this is the velocity with which the gun recoils back. Now, the negative sign is again a proof of our correct physics thinking. Negative sign means if the bullet has a positive velocity in right direction, the negative sign proves that the gun is moving in the left direction, because velocity is a vector quantity, and the negative sign will be proof of some motion in the opposite direction. So that proves our point. Okay, so this question and its working is very important to understand, because this is kind of exam question. Thank you.